There are variables that we can use in analyzing the other variables that includes nominal data or categorical data. When we say nominal data, the data is nominal because the data itself is in text or in words. So we are not using numbers. And if you are going to analyze that to another data that is categorical, we are not even using the numbers. So sometimes we have to analyze this nominal data with the data that is Likert. So if you want to know whether there is a relationship between the two variables, then we will use the chi-square for that. Okay, so example of this nominal data, example, we have the gender here. And for the gender, we have the code 1 and 2. 1 means in this example is male and 2 is female. And then another for civil status, we have 1, 2, 4, and 3. The 1 means here single, 2 means married, 3 is separated, 4 is widow. What I did here is I used the coding as the data here because that will avoid from error, from a sensitive error of different characters in the Excel because that will be treated independently. So to avoid that error, I am going to use the code. Now we also have the ages. This set of data is actually not nominal. It's numerical, and we can rank them. However, there are researches that the researcher will give the option so that only respondents will choose as to what scale their age belongs. So that sometimes happens. So that's why in this case, we are going to change this to categorical form or making a scale out of this response. So we will now try to analyze if gender is related to satisfaction. Our problem here is to know whether uh, is gender related to the satisfaction of the respondents, or is their satisfaction based on the civil status, or the civil status affects their satisfaction level. The same analysis with the motivation, no? So that's the analysis. That's why considering that we have the data that is nominal, of course, in our mind, if you think of the relationship, we can choose chi-square for that. Now, in the satisfaction, let us be guided that there are 10 scales, 10 questions used in the measurement of the variable. So it's S1 to S10. So these are the questions. And then in the next column, we have the total satisfaction. I know you know already how to compute this. You simply type equals, then highlight all the scores under study. And we also have the mean satisfaction. So that is equals average of all the data from S1 to S10. Now, the next column here is the count satisfaction. It's empty because we still have to fill it up here now. And in the analysis of chi-square, we are not going to use the total nor the mean because if we use the total, there are many different values and these are taken independently, unique from each other. So that means in the chi-square analysis, there are so many columns to be considered or rows. Same with the mean satisfaction. Every unique value is analyzed independently. So what we do is to limit that options, we have to use the scale itself. Example, if this is a 4-point scale question, so from the 4-point scale, we will just transform or convert 2.7 into whether it's 2, 3, 4, or 1. So you will not do the rounding off. That's wrong. You will not round off, but you will just refer it to the scale. And what is the scale? So you remember that in every Likert scale, you should identify the highest and the lowest score. Now, if it's a 4-point scale, of course, the respondent can give only the highest of 4 and the lowest of 1 if that is in your option in the questionnaire. Now, we have to get the range. That is actually the difference between the highest and the lowest. And then you should know the number of scales. If it's 4-point scale, of course, there are 4. But if it's 3-point scale, it's 3. Or if it's 5-point scale, it's 5. But in our example, we have 4-point scale, so it's 4. Now, the interval is computed by dividing the range and the number of scales. So you divide 3 by 4 is 0.75. Now, what we will do next is let us identify the scale 1, 2, 3, 4. So in satisfaction, That means not satisfied, less satisfied, satisfied, and very satisfied. The same with the motivation. But the question is, what are the values so we can say it belongs to 1, 2, 3, or 4? So we will consider the interval here, and we start from the lowest expected response, that is 1. And then you add this one by the interval. So to be safe, you have to equals, click this one, plus 0.75. And so you can drag down. Okay. And then if you notice, it's 1.75 here. So before 1.75 is 1.74. Before 2.5, it's 2.49. And if before 3.25 is 3.24, and the last is 4. So meaning all the values that belong to this range is 1. All the values are 1 here. If the value belongs here, so it's 2, and so on and so forth. So let's try to go back to motivation. So 2.53 manually, 2.53 belongs here. So we can say that it is 3, or satisfied, or motivated. So instead of doing that one by one, it's good here that we only have 30. What if you have 384 or 1000? So we'll just do the shortcut command equals VLOOKUP. Be careful. Then open parentheses, you click the value to be referred in the table. And then comma, you just highlight the table. So you can highlight that all until here. So if you see now, it's 8 AO10 to AS13, comma, you have to refer to which column. Is it first, second, third, fourth, fifth? So example, if you want motivation, so it's in the fifth column, so you can type there 5. If you want count, it's in the third column, so you can type that 3. So let's try, say it's 3, enter, and it's 3. But what if we change that to 5? So we can see the words. Okay, it's motivated, less motivated, and so on and so forth. But for us to use the count easily, so we will just go back to 3. Now, if you drag that down, as you notice, there are values that cannot be seen. That is because the reference table is moved. Look at the first is not now considered. It moves down. So that's the problem there. If you go back here, look at, of course, it cannot be seen because the table moves down. To avoid that to happen, we have to add $sign before the letter, between the letters and the number. So how do we do that? Place the cursor between the last letter and the number and press F4. That's it. And again, in AS, press F4 after the cursor is placed between. That's it. Enter. So this time, you can now double click or drag that down. So everything now is replaced correctly with the proper values. Now let's go back here to the satisfaction. Instead of doing that again, VLOOKUP, you can just copy that and just put it here to satisfaction. Okay, and then drag down. There's no problem. No, we should not worry because the putting the $sign between these letters would mean the table should always be referred on the same table, not moving down. And then, of course, the satisfaction shall also be referred to that scale because the same satisfaction has 4-point scale. But if this is another scale, example 5-point scale, we have to compute again and make another scale. And so we change the table reference. So in this case, we have used the same reference table. So that's the count satisfaction. Okay. Now, in the analysis of chi-square, let us try to copy this. Okay, we will just bring this to another sheet so that we will be guided as to, okay, I'll paste it there. So we'll be guided as to what to do next, using the Excel. So it's very clear here. We have gender, ages, and civil status. Remember that there are 30 respondents under this study. If you go back to our data bank, so our data bank, there are 30 respondents here. The last is 30 respondent. Okay, let's go back here. Now, we have to analyze that against the satisfaction and motivation. So we will just copy the count satisfaction, not the mean, not the sum. We'll copy the count and we paste it here, values. And we also copy the motivation in the analysis so that You can already prepare all the data in one sheet. You have to look at the statement of the problem as to what else are being analyzed. Okay, so we call this examples here, the gender, age, and civil status. We call that as profile of the respondents, usually being asked in the statement of the problem for a research problem. What is the gender of the respondent? What is the profile of the respondents in terms of gender, age, civil status? Okay. So these are now the values to be analyzed using chi-square. So first analysis is gender related to satisfaction of the respondents. And how do we do that? What we need is we have to put that in a cross tabulation. So you should know how many male are 4 or 3 or 2 or 1, or how many females are 1, 2, 3 or 4. So if you do that one by one, so this is male, these are males, no, that 3 respondents, then you have 2, 3 and 1, 4, and so on and so forth. But you will not do that manually because we can use the shortcut command in the Excel. So what you will do is you just go to insert, then look at the pivot table, and in the pivot table you have here select the range. So meaning you can select that here. Okay. Okay, all. Anyway, it depends on what we will analyze. So you just make sure to put that here. And then new worksheet or worksheet existing. So I'd like to put this here after our data set here. Okay. So as you notice now, this is our inserted table. We cannot have yet the value. But we have an options here. We have options here. Example, you want to analyze gender. You can put gender in the column. And also, you would like to analyze satisfaction. You put satisfaction in the rows. But if you notice, you are not yet provided with the total supposedly is 30. But you have here 45 because you have here the values for gender sum and sum of satisfaction. So what we need is, instead of sum, you have to go to value field settings. Instead of sum, you have to change count. Okay. What happened now is we will delete the satisfaction to avoid error. Okay. So we can remove that field. Now let's try to look at what happened to the table. It's 30 already. Okay. So what does it mean? Okay. So if you notice here, these are the rows. Okay. The rows are 1, 2, 3, 4. So these are actually the satisfaction. And you have here the gender 1 and 2. 1 is male, 2 is female. So whatever is being used in the coding, that refers to the corresponding data set. So you notice that for male, 1 is very dissatisfied, or very or not satisfied. There are 3 who are less satisfied, 8 who are satisfied, and 1 very satisfied. However, for female, this 2 represents the female. For the female, 1 is not satisfied, and then 5 are less satisfied, 10 are satisfied, and 1 is very satisfied. So if you look at, the total must be 30. Okay, so we need that. And then we will also make another table. So you will just we'll just go back to another table analysis after we solve this one. Okay. So what we will do now, so we have this table, we can copy this because we need to manipulate in another sheet. Okay, I'd like to put it here. And I'd like to put the grid lines. Okay, we have to look at now. Okay, so let us try to change this. Say this refers to the gender. Okay. So let us change this to male. And let us change this to females to avoid confusion. And we have the total. Okay. So what you will do here, in order to start analyzing with the chi-square, remember that the chi-square actually, the chi-square, we can put the chi-square. The formula for chi-square, we can look at that in the internet. So let's try to look at in the internet. Okay, let's say here chi-square formula. Okay, so you can see here, it's x squared equals summation of O sub I minus E sub I squared over E sub I. So you said here, x squared is the chi-squared values, the sum of all the operations. And then O is the observed value, and E is the expected value. So in other words, we need to subtract first the observed by the expected, then square that, and then you divide it by the expected, and then you get the sum. So to do that in our um, chi-square manipulation here, so let's go back to the gender. So this is gender versus satisfaction. So what we need here, I'd like to insert. Okay. Okay, I will just copy this to another sheet so I can delete that. And say satisfaction. And this is for male. And this is for female. And then we have the total. Okay. So I think I can delete this already. There. So I will just highlight that. And then highlight this. Another color, meaning that represents to, I know this one. So we'll not highlight the given data. Okay, that's it. So how do we solve now? I will insert before and after. And then, okay, I will also insert for this all, because I will make a label for us to compute easily. Okay. So I will say we can have here the expected value, the expected based on the formula representing letter E. And then these are the observed. Observed. Okay. This is the observed. So meaning all of these are the observed values based in our data set, based on the result of the study. And then we have here the x squared. So I'll copy that to all. I'll put it here. There. And then I am going to uh, clarify by making it bolder there. So we can limit as to where we are going to analyze. Okay. That. However, we still have to get the total below here. Now, what is the total? I'll make this data at the center. So the total actually is the sum. The sum of the values, the observed values. Okay. 13 for that, and here is 17. So what is the sum? 30. Meaning if you add 13 by 17, 30. And if you add this all also, that is 30. Okay. So what we will do now, we are going to get the expected values. And we will get the x squared. So meaning we divide. Okay, so if you go back to the formula, so you have observed minus the expected values square. So you have to square that. And then, okay, we have to get the expected values. So after that, you add that all. Okay, so the result now is, okay, the chi-square. So I think we have to get first the expected value. And how do we get the expected value? The expected value actually is, okay, so let's look for some reference. Okay, expected value for chi-square. Okay, we can use the images so we can be provided with a score. Okay, the expected value is actually, okay, okay. So look at here, example, it's the 48 times 40 over 60. So if you look at that example, okay, if we visit that, so, okay, we are now directed to YouTube actually. Okay, so I'll not, we don't need that. Okay, we'll just have here. Okay. We look for another sources easier to be understood. Okay, for the expected value. So it is actually the product of the total in row and column divided by the overall product. I cannot find it here in you in the internet. Okay. So how do we do that again? So I'll go now to the uh, analysis. The expected value is actually you get the sum. That's why you have here the sum. You have here the sum and you have here the sum. So I will just make that in different color. Example, this one. The expected value, I'll make it larger. The expected value is equal to the product. No, I'm sorry. That's the satisfaction. So we'll start here. I will highlight that with yellow. Okay, there. So that is equal to, let's make it larger. That is equal to the product, which is 13, times the product, no, not the product. It's equal to the product of the sum. So the sum of this male and the sum of this row, which is 2. You put that in the parentheses and then divide this by the overall total, which is 30. So you don't need to click that, but you have to put 30. Okay. So again, it's the product between the total of the column and the row divided by the overall total. And then the same thing, you are going to make the operation. So 17 times, okay, this one, and then divided by 30. Okay. How about here for the second? So this time equals, the expected is equal to 13 times the sum here, which is 8, divided by 30. Okay, so let's try to drag that if it will work here. And we will check. Okay, as you notice, okay, so we will just move this one again over 30. That's it. And in here also, again, we'll do that manually. The sum times the sum of the row divided by 30 as the overall. We'll do that here. Equals the sum of the column times the sum of the row divided by 30 again. And in here, that is equal to the sum, which is 17, times the sum of the row, which is 18, divided by 30. In here, the last one equals the sum, which is 17. Let's put that in the parentheses, times the sum, which is 2, divided by 30. So let's check if we are doing it correctly. This one, correct. This one, correct. Okay, look at the highlighted values, correct. Okay, correct. Okay, correct. Okay. 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 So that means we are going to, we have already the expected and the observed. So in the formula, if you remember the formula in the internet, formula for chi-square, you have to subtract the observed by the expected, then you square the result and divide it by the expected. So we'll do that. So in here, equals, subtract the observed minus the expected, then you square the result. Okay. And then I put that in again in the another parenthesis because we still have to divide it by the expected, which is this one again. So be careful with that command. Enter. Which I can copy this one here, and we will check later if we have the same or correct computation. That is to avoid error. So again, this is the x squared, meaning you have to, what happened here? This is the expected. You have here, you subtract observed minus this one expected, and then you square the result. Then after that, divide it again by the expected. You put that the squared inside the parenthesis. This one, the same idea. Okay, correct. We'll check this one. Yes, correct. This one. Yes, correct also. This one. This is the observed and expected. Expected and observed. Okay. This one. Okay, correct. So, what we need now is the sum of x squared. Or we call that the chi-square value. So, the chi-square is equal to, we'll just get the sum. Sum, open parenthesis. Sum, click this one first, comma. This one second, comma, this one, comma, this one, comma, this one, all the x squared, comma. Okay, please don't be confused with the location of the values to be added. So if you check, you simply added the values in here, the x squared. Because in the formula, if you look at the formula in the internet, it's summation of all of those. So that's x squared, chi squared. Okay, so just check it properly. And our chi value now is 0.19. Now we have to find now the critical value or tabular value. The tabular value is with the degrees of freedom. That is, the degrees of freedom is rho minus 1 times, I'm sorry, that is rho minus 1 times column minus 1. What does it mean? How many rows minus 1? How many columns minus 1? If you look at, there are two columns, male and female. If in case this column has a total of 0, delete that column. We will not count that. But in case the total is 13, we'll look at the total as our identity that we can still count that as number of rows. For now, columns rather. For number of rows, here 1, 2, 3, 4. If the total here is 0, delete that row, all that row. So in this case, 2 minus 1 is 1. And there are 4. 4 minus 1 is 3. So our degrees of freedom is, what is that? 1 times 3, it's 3. Correct? Now this time, you are going to refer that to the tabular value. So the tabular value now is, we will find that in the internet. We call that as the chi-square tabular value. Okay, so there are many tables in the internet as our source, as our reference, like this. Okay, I think it's very clear in this part. So we'll just go to 0.05, and then our degrees of freedom, as you notice, the DF is the degrees of freedom in the first row. 0.05 is our degrees of freedom now is 3, because 1 times 3 is 3. You go to 3 under 0.05. It's 7.815. 7.815. That is from this source in the internet. So that is equal to 7.815. That is our 3, 0.05, 7.815. So that's our critical value. Now, how do we now decide what is now the result? So you will have to make a summary table. Example, profile. And then you have here the chi-square value. And then you have here the degrees of freedom. Then the tabular value at alpha 0.05. And then we have the decision. And then we have the interpretation. Okay. Okay, so example, we started computing the gender. And then the chi-square value that we have is that one equals. You copy this chi-square value. What is our degrees of freedom is 3. Tabular value is 7.815. Now, for us to decide, for the decision, in this case, okay, so the chi-square is less than the tabular. It has to be greater than. So in this case, it's less than. So our decision is insignificant. And our null hypothesis will be accepted. What does it mean now? If the null is accepted, what does it mean? That means they are not related. So it will not matter whether you are male or female. The satisfaction depends on it. No. So in that case, you have to check another variable as to what matters with satisfaction. So that's the case. And then if you continue, you have there the age. And then you can have also the civil status. And what you will do again is you are going to solve that based on the given. Okay, so that's the chi-square. Let's try to look at now. Let's try to use the data for see that's the we'll look at the civil status this time and the satisfaction. Okay. We can also analyze gender with the motivation. Let's try to analyze gender with motivation. So again, we have to insert again. Insert pivot table. We highlighted that everything. And then, okay, I'd like to put another pivot table here. There. We have here another type pivot table. I'd like to put gender in the column. And then motivation now, this time, in the row. And then careful, I will delete the sum of motivation. Remove that field. The sum of gender, change that to count. Now it changes now to 3. So we can use this idea now. So for motivation, there are only 3. Okay. So we can copy that for the computation. Okay. And we can compute that here again. So in this case, this is the male and this is the female. And these are the motivation level, the 3, 4. So let's try to name this as gender and motivation. Okay, so again, so let's insert. So you can perform as what we did in the previous table analysis. Okay, we can name this as observed. We can write the expected. We can write the x squared. Again, we need the expected, observed, then x squared. Again, we have the expected, observed, and then the x squared. And then let's try to highlight this. Okay, so I think we'll just bold that. Okay, so that it's not, it's good to the eyes. Okay, so let's try to there. And the last one. Oh my God. We will just stop here. Okay, this is the last one. Okay. So these are the motivation level based on the scales that we used, and these are the gender. So these are actually the observed data, and what we need is the computation. So again, you will get the total. You have to get the total, otherwise we cannot get the expected value. So equals sum, this one, comma, this one, and that one. Enter. So you can drag that here. Okay. You can also drag that here. 30. Okay, so the total is 30. That is equal to your number of respondents. Now, so to get the expected, if you remember, equals, we have to multiply the total, the 13, times the total here, the 12, divided by 30 because the total overall is 30. Okay, so let's try to do that here. Equals this one times 12 divided by 30. Again, this one equals, okay, this one times this one divided by 30. Okay, again, this one times 16 divided by 30. I'm sorry, the formula is wrong. We have to put another parenthesis. And then again, this one, 13 times 12, I mean 2 rather, divided by 30. Okay, proper parenthesis. This one, 17 times this one, divided by 30. Okay, that's it. Now we will look for the x squared. So we'll go to the formula, equals. If you remember, I will have already the double parenthesis. Observed minus expected. Then we square that. Close parenthesis. Divide that by the expected. And that's the result. So it's easier in this part because we can copy paste this to another cells. Okay. There and there. Okay. So that's it. Now we have to get the sum, the chi-square, which is the sum of the x squared. So you get the sum equals this one, sum, open parenthesis, this one, comma, next, comma, next, comma, happened here? We add that together with this and this one. And last, this one. So be careful what we are adding. We are looking at under x squared. So be careful to avoid error. So the sum here is 0.05. And if you look at our degrees of freedom, is how many degrees of freedom? So male and female, it's not 0. So 1. 3 minus 1 is 2. So 1 times 2 is 2. Degrees of freedom is 2. Now you look at the table, our reference. So you go to 0.05. It's 2. It's 5.991. So our tabular value is, what's it? If you remember, it's 5.991. That's our tabular value, 5.991. And this time we are going to make summary table again for us to interpret. So the same idea with this. Okay. So we will just copy this one and then put it here, and then we have to put the title. And the title is relationship. You can say relationship, or we can say profile and motivation, because in the above table was profile and this one was profile and satisfaction. Okay, so that's it. We will change the values now. So in for the gender and the motivation, so the value is that you can put 3 decimal places is 0.051. 3 decimal places, you can say 0.051. Degrees of freedom is 2. Tabular value is 5.991. Now, if you compare now the tabular value with the chi-square, so it's insignificant because, again, the chi computed is less than the tabular. It has to be greater than to be significant. So, again, the decision is insignificant and accept the null hypothesis. That means, again, not related. So, in other words, the motivation of the students does not matter with gender, whether male or female. So, you have to continue that all, finish that all, and you are done with the analysis of the data using chi-square. Let's go back to the age. In this case, all you have to do is to make a scale. Okay, so and you can decide how the same idea as what we did here, but like this. However, in here, you refer to the highest there in the age and the lowest, and the range, you subtract the highest and the lowest. For the number of scales, you decide. You can decide it's either 5 or 6 or 7, and then you have the interval. And you will make a scale here, and then you will use that as count. Example 1, 2, 3, 4, 5. Then reflect that there for the age. You will add column here. You reflect that here, and then you analyze that with the satisfaction. Or it's good that if your research question in your questionnaire is already in scale. Example 10 to 20 years old, 21 to 30 years old, like that. No, but if in this case, you can use also another test, not the chi-square. But if you want to use chi-square, you convert this to scales. Okay, I think that's all. I hope you learned a lot to this discussion. Thank you.